Hello and welcome guys. Do you want to make the SQL query run faster? Do you want to become a hero in front of client by saving cost? Do you want to be confident to justify the SQL performance to application team? Then this course is for you and you are at the right place. Welcome to SQL Tuning course. What you'll learn from this course? You'll learn SQL Tuning basics. You'll also learn the tools to diagnose SQL performance. And we have a very good real-time experience, so you will be learning proven methods to identify the bottleneck and provide solution. And you will also be able to explain the SQL performance cause and solution to the application team, and you can justify the problem statement. You can narrow down the problem and get the root cause. You can improve the performance of SQL as per business requirements. And you will become a hero in SQL tuning and impress clients. Who is this course for? This course can be taken by Oracle DBA, Oracle performance enthusiasts, and Oracle application DBA, and anyone else who is interested to learn SQL tuning. Why do you need to take this course? Why? Because you will learn the techniques which are distilled and proven from the real-time experiences for many years. It is very important for DBA to learn SQL tuning to survive any database outages in terms of business impacts. This course is unique, which helps DBA to face a performance issue confidently. You will also gain practical knowledge, and that is more important for SQL tuning than theoretical knowledge, which is available here. Again, I would like to thank you for enrolling this course. I hope you will enjoy this course.
Hey guys, in this session let us install Oracle Linux in VirtualBox. Open VirtualBox, then click on New. Provide a name for the VirtualBox. Choose a location where you can store the VM. Choose the OS type as Linux and Oracle 64-bit. Click Next. Give 8 GB RAM. Click on Next. Click on Create. Click Next. Choose Default, then click Next. Here you can give the size of the VM. I give 300 GB. Also choose the location of the VM. If it is already chosen, then you can ignore it. Otherwise, you can click on this icon and select the folder where you need to store the VM. Click on Create. Now go to Settings, click on Network, click on this drop down window, choose Host Only Adapter, click on Allow All, then click on Adapter 2, Enable Network Adapter, choose Bridged Adapter, click on Allow All, click on OK. Now you can double click this VM. You need to select the disk. You would have downloaded Oracle Linux ISO file. So you need to choose that ISO file. If you click on this icon, then if you click on Add, you need to give the location of that ISO file where you have downloaded it. Okay, then click on Open, so that ISO file is displayed in this window. You can select it and choose. Okay, once you choose it, you can click on Start. Now just choose install Oracle Linux 8.2.0. You can click on continue. You have to choose the language over here. Here click on installation destination, click on custom, click done, choose standard partition, add this mount point. First we need to add root mount point, which is slash. Here we can give 30 GB. Then add swap. Here you can just give 4 GB. Add slash uo1. Here you can give 188 GB. And add slash uo2. Here you can give 84 GB. Okay, so still 1 GB is available, so we can just try to change it over here. Now we have utilized almost all the available space. Click on done, click on accept changes, go to software selection, and you can leave it as default. It should be server with GUI. You have to select all these options. Click on done. Then you have to choose time and date. As per your location, you have to choose the time zone. Go to network and hostname. So here you can turn the network on for both the adapters. Click on configure. So here go to IPv4 settings. Choose the method as manual, and here you can provide the IP address of your VM. You can give any IP address, okay, and give the subnet mask. So the IP address of the first three the first three octets of this IP address should be 192, 168 and 56. Okay, and the last number can be anything. You can give either 100 or 101 or any number less than 192. Okay, now just save it, click on done. You can click on begin installation. Now the installation is started. Just give a password for root. Here you can give some username. Okay, I'll just give us Aura. Click on make this user administrator checkbox. Then you can give a password. Click on done. Now you have to wait for the installation to complete. Now we can click on license information. Click on this checkbox. Click on done. Click on finish configuration. We have successfully installed Oracle Linux in VirtualBox.
Hey guys, in this session let us configure PuTTY to connect to this VirtualBox. Let me log into this VM, log in as root, give the password. You will be prompted for some confirmations, so you can just choose your language, click on next, just click on next. You can turn off privacy services, click on next, skip it, yeah. Okay, so now you can start Oracle Linux server. You have to configure the network. Click on wired settings. So you have to turn on both the adapters. Okay. Click on this settings icon. Since we have already configured the IP address for this VM, it is already present here. The only thing that we have to do is to enable this checkbox. Okay, so this option allows the VirtualBox to enable the network adapters even if I reboot the machine. Okay, if I just disable it, then for the next reboot the network adapters will be turned off. Okay, so just click on this icon and apply. Also make sure that the network adapter for internet is turned on, otherwise you will not be able to connect to internet using from your virtual machine. Okay, click on apply. So now click on this power icon and restart again. Just open PuTTY software and give the IP address of your VM. Just give some name for your VM and save it. Go to appearance, choose the font size and font type. You can choose anything which is good. Okay, I will just increase the font size and go to colors, click on default background. Just give some background for your PuTTY window. Modify the default foreground. Now you can go to session and save it. Click on this SSH, go to X11, click on enable X11 forwarding. Here you have to give localhost colon 0.0. Now save it again. We have configured PuTTY to connect to this virtual machine. Just click on this open. Just wait for this VM to complete. Now what you have to do is just open PuTTY again, select the configuration that we have already configured before, click on open. Okay, so now you get this window. Okay, you can just accept it and type root password. Okay, we have successfully configured PuTTY to connect to the virtual machine. Hey guys, in this session let us configure Oracle prerequisites which are required to install Oracle database software. Before that, you may get an error related to Ethernet adapter. If in case you face this error, just open control panel and go to this location. Just select this VirtualBox host only adapter and right click on this. Click on disable. Okay, I'm not going to disable it now. Again right click and enable this. Okay, so you're going to reboot this adapter to solve this error. Okay, if you don't get any error related to this second adapter, then it's well and good. You don't need to follow these steps. Okay, sometimes if you click on this icon, you may get 3 dots over here. Okay, you may not get a white icon like this. Okay, so that means that the Ethernet adapter is not enabled. Okay, now let us perform the initial configuration in the server. Open hosts file and provide the IP address and the host name. Just save it. By default, host name is saved as localhost. Okay, so we have to change the host name using hostnamectl command. Now we are going to install this Oracle database pre-install 19c. This package installs the Oracle user and it also installs certain packages which are required to install Oracle database software. Also update M repository. This may take a lot of time, so let me open a new session. Just give a password for Oracle user. Now I can log into Oracle user. You can create the directories. So let me log into root user itself and create these directories. Provide the permissions to all the mount points related to Oracle. Specify the hard limit and soft limit for Oracle processes and save it. Set the environment variable script. Just refer that script location to bash profile. Configure database startup script. And shutdown script. So this script will set the environment variable, and it also automatically start up the database when the server is rebooted. Just give permissions to the scripts directory. Disable firewall. We may get some trouble if we don't disable firewall related to the network. So that's why we are disabling firewall. Also, disable SE Linux. This is also kind of a firewall in Linux. We have to disable this. Otherwise, we may get some challenges when we SSH. So just type in get enforce and set enforce 0. Okay. So get enforce means I'm checking the status of SE Linux, which is running currently. Okay, so that's why I disable it. Create a directory for Oracle inventory and also the Oracle inventory file, and just provide this information inside this file. That's it. We have configured the initial prerequisites to install Oracle database software. Now we are good to install Oracle database software in the server. Okay, just wait for this M repository update to complete.
Hey guys, in this session let us install Oracle database software. First open WinSCP. Just click on new site. Give the IP address of your VM. Give the username and password, save it, click on login, give the password again, drag this software file. So before that we need to locate to the Oracle home location. So now you can drag this zip file. So this left side is the Windows machine and right side is the Linux machine. So you need to locate where your Oracle database software file is residing. Then you need to drag that file from Windows to Linux. Now go to Oracle home location, unzip this software file, open Xming software. Once the software file is unzipped, you can execute this command. Now execute run installer. Oracle Database 19c installer graphical window is opening. Click on setup software only, click on next. Single install database installation should be chosen, click on next. Choose enterprise edition. Then Oracle base directory is default. Leave these options as default. Click on next. You will be getting a warning for swap size. You can ignore this by clicking this checkbox, ignore all. Then you can click on next. Click on yes. Now click on install. Oracle database installation is Oracle database software installation is started. So once this installation complete, we are ready to install Oracle database. Okay, and you will be prompted for executing the root.sh script. So let us wait for the prompt to appear. Execute this root.sh script using root user. You can enter. So once you execute this root.sh script, click on OK. Now the Oracle database software installation is complete. Click on close. In the next session, we'll install Oracle database. Hey guys, in this session, let us install Oracle database. Just locate to Oracle home bin directory. In the last session, we had installed Oracle database software from the Oracle home location using run installer. So now I am locating to this directory. Just invoke dbca. Also make sure that Xming software is enabled. So you can click on next, click on advanced configuration, click on next. Choose general purpose or transaction processing, click on next. give a database name on the SID here, and if PDB is required, we can enable PDB, but as of now we don't require PDBs. So click on next, click on next. Just enable fast recovery area and archiving, and you can give a location for FRA. So you can give you can create a new location. So let me open Putty. Let me just name the directory as FRA under /uo2 and choose that path. Click on OK. Click on next. So we need to provide permissions for this folder. Just provide Oracle and go install user and groups for FRA location. Now if you click on next, yeah, we don't need to create a listener as of now. Click on next, click on next, leave this as default. Click on add sample schemas in the database. Click on next. You can untick this checkbox if you need Enterprise Manager in your database. Okay, so I don't need Enterprise Manager, so I will remove this. So if you want, you can just tick this checkbox. So this is just an express edition, so I don't want it. Click on next. Just give a common password for all administration accounts, and you can click on yes. Now we'll create the database. Click on finish. Just wait for the database installation to complete. Now the database installation is complete. Click on close. Now just set the environment variables. Specify SID of the database. And log into the database. We have successfully installed Oracle database.
Hey guys, in this session let us see the high-level architecture of Oracle database. I am not going to explain all the components in this architecture. Since we are going to see only SQL tuning, I'll be explaining this architecture in terms of SQL processing and execution. Consider that an application is executing a select query. Okay, so once the client executes the select query, user processes will be allocated, and these user processes will send the SQL statement to server process, where listener will be listening on port 1521. Okay, so this listener authenticates the incoming connections and it will fork the connection between user and server process so that they both communicate with each other. So once the server process is allocated, private SQL area also will be allocated for each and every session which are executed. So consider that there are two users, user A and user B. Okay, so both these users may have some different requirement. So user A may be executing some different query and user B may be executing some different query. Okay, consider user A is executing select query and user B is executing insert statement. So in this case both are different, right? So all these session related information should be stored somewhere in the database and need to be identified by Oracle database, right? So all those private session related information will be stored in private SQL area. Okay, and in this private SQL area cursor will be allocated. So this cursor acts as a pointer to the private SQL area and it also represents the individual session to enter the shared SQL area where all the shared SQL related information will be stored. So what are those? Hash value, plan hash value and SQL ID. So these are all the basic shared SQL information which will be stored in SGA inside share pool. Okay, so these information are very important for every SQL ID which is executed in the Oracle database. Okay, so how that SQL statement is identified inside the share pool, inside the library cache. So it compares between the existing hash value, plan hash value and SQL ID. Okay, so once this SQL statement is executed, this SQL statement should be having these information, and if these information are already existing inside share pool, then that is called as soft parse. Okay, so if these information are not matching with the information related to this select statement, then it is called as hard parse. Okay, so in hard parse all this information need to be created from scratch. They have to be newly generated. So that's why hard parse is considered as expensive operation, right? So if it is a soft parse, we don't need to generate all these information again, right? So that's why soft parse is always good compared to hard parse. So let me give you a real-time example. Consider that there is a library. Okay, so inside this library there are multiple racks of books. Okay, so on day 1 I am just going to search for a book called A, but I am not going to take that book. Okay, I am spending a lot of time and efforts to find that book inside the library. I am not going to take librarian's help. Okay, I have found out that the book is existing inside the library over here, 4th rack, 4th row or 3rd row. Okay, I have identified the book and I'm not taking the book. Okay, I have decided to take the book on day 2. So on day 2 I'm again coming to the library. Okay, and I'm searching, and I will not be searching for the book since I have already found out the book on day 1. So it will be easy for me to directly locate the book over here, right? So just relate this example to shared pool in SGA. Okay, so if this, consider that this SQL statement is the book, okay, and person. So this is the person, and person as server process. Okay, So here server process will search inside the shared pool, inside the library cache for the SQL statement information like hash value, plan hash value and SQL ID. So here consider that those plan hash values and SQL ID as the book A. Okay, so I have already found out the book on day 1, so that's why I'm doing a soft pass. So on day 2 I'm doing a soft pass, but on day 1 I have to do a hard pass. Since I have to find out the book and I need to spend a lot of time and I need to use my brain to find out the book, right? So this is conscious effort. On day 2 I have subconsciously identified the book, right? So this is how SQL processing works, and inside this library cache parsing happens. Parsing means checking the syntax of the SQL statement and checking if the table existing inside the database or not, and whether the table user is having permissions to access the table or not. All these informations will be performed inside library cache. Okay, so they are syntax check, semantic check and shared pool check. Okay, so this data dictionary cache decides whether the user is having permissions on the object or not. And coming to result cache, so this result cache stores the result sets of the SQL statement. So if a particular SQL statement is executed repeatedly for multiple times on the database, and if the result set is not changed, so in those cases those result sets can be cached inside the result cache, so that additional disk IOs are not required. Server process don't need to scan all those data blocks from disk to memory. So that is the fundamental, right? So whenever a SQL statement is executed, so there will be a buffer and there will be a disk, and all those data which is residing in the disk will be scanned to buffer. So this is how every computer works, right? So we have a RAM and we have a disk. So all the persistent or permanent data will be stored in disk, and all the temporary data will be stored in memory. So if you switch off your laptop, so the next day you will be able to see all those files again inside your laptop, right? So those files are stored in disk. That's why you are able to see those data. But if there are any temporary files, or if you have opened any application, right, so all those applications are executed inside the memory. So the next day if you open laptop, all those applications will be closed. Again you need to reopen those applications, right? So this is how Oracle database works. So if all these checks are completed, then it has to scan the data either from buffer or disk, either from memory or disk, right? So it has to search for the data which is residing inside the buffer. So if the data is already residing inside the buffer cache, it is called as logical IO or LIO, we can say. And if the data blocks are not residing in buffer, and if it is residing in data file, then all those data blocks needs to be scanned from data file to buffer cache, right, by the server process. So this is called as physical IO. Okay. Also, for each and every data block which is residing in buffer cache, there is a duplicate or cloned copy of the data block. Okay, so this cloned copy is called as undo, and this undo is also called as old records or old data. Okay, and this old data is retained to satisfy read consistent purpose. So these blocks are also called as read consistent image of the original data block. So let me show you an example. Say for example, there are two users, user 1 and user 2, and user 1 is, say for example, scanning this particular block. He is executing a select query to retrieve the records from this data block at 10 a.m. Okay, after 5 minutes, user 2 at 10:05 a.m. is modifying the same data block which is accessed by user 1. Okay, but user 1 is still accessing it at 10:05 a.m. Okay, user 2 is deleting some records from the same data block. So user 1 is accessing this particular data block till 10:10 a.m. Okay, so user 2 has deleted the records from 10:05 till 10:09 a.m. So in this case, user 1 should not see the deleted records of user 2. Right, so in this case, what can be done? Say for example, if I am accessing a particular website, okay, two users are booking a ticket for a movie, and first user has paid the amount, but second user has not paid the amount, but both the users are accessing the same seat. Okay, but user 2 has accessed the website before user 1, but the only difference is user 1 has paid the money. So in this case, user 2, unless until he refreshed the application or the browser, you will still see that that particular seat is available, right? But once he refreshed the browser, he will not be allowed to book that ticket anymore because user 1 has already paid the money. So this is where the read consistency is required. User 1 should not be able to see what user 2 is doing unless until he refresh that particular browser. Likewise, here user 1 should not see the modifications performed by user 2 unless until he exits the session and again log into the session, right? Until 10 a.m. he should be seeing the older data of 10 a.m. not the deleted data at 10:05 a.m. Right? So for this purpose, what Oracle does is, so once user 1 scans or retrieves the data from this particular data block, it generates a cloned copy, right? And user 1 will be searching for that cloned copy of the original data block rather than the original data block itself, so that user 2 directly go and modify the original data block, so that user 1 will not be able to see the modified records, right? So why? Because he is accessing the older rate consistent image of the original data block. So once he or user 1 exits the session, this old rate consistent image of the block will be removed. Okay, so they will be no longer available. Why? Because the original data block is already modified. So again, if we log into the session, he will not be able to see the older records. Okay, so this is a high level view of undo. So if a particular user modifies this particular data block, say for example he is inserting some records to this data block, obviously there is a change in the original data, right? So all those changed records will be stored in the log buffer immediately. Okay, so all those changed records again will be stored in the disk in online read log file. Say for example, if this particular data block contains 100 rows, Okay, just assume it. If I insert 1000 rows in this particular data block, the number of rows will become 1100 rows, right? So all those changed records, all those 1000 records which are recently modified will be suddenly saved in the log buffer. Okay, so I'm not going to explain you about other background process and all these stuffs because it is not required for SQL tuning purpose. Okay, so in the next session we'll see about SQL processing. Hey guys, in the last session we had seen Oracle database architecture at a higher level. In this session, let us see SQL processing architecture. So we already seen how the SQL enters the shared pool and perform syntax check, semantic check and shared pool check at a higher level, right? As we already know that user process communicate with the server process, and user process send the SQL statement to server process, and server process collects that SQL statement and it enters the shared pool for SQL processing, right? So this is where actually the SQL processing starts. Okay, so once this SQL statement enters, say for example, select star from the table. Okay, so I have taken a screenshot of the select query and it has retrieved some records over here, right? So this select query is executed from SQL Developer client. So this is the user process. Okay, so this client contacts the server process in the background with the database. Okay, so now it enters the shared pool. Select star from XDBL is entering the shared pool. So once it enters the shared pool, it checks for the syntax. As we already know that there is a SQL standard for each and every database, right? So for Oracle, there is a SQL standard and there is a set of keywords which are reserved. We cannot use our own words to communicate with the database, right? So if you are using SQL, instead of select, we cannot use pull, grab, or something like that. Okay, the only keyword which is supported is select, right? So first it checks for the syntax. Okay, if the syntax is wrong, so here instead of from I say fro, so Oracle throws an error or a 923. Then it goes for semantic check. In semantic check, Oracle checks if that particular object is existing in the database or not. Okay, if the object is not existing, then Oracle will throw ORA 942 error. Okay, so if the object exists, then it will go for the shared pool check. Okay, so if the first two checks are passed, then it will go to the third check, which is shared pool check. Okay, so in shared pool check, hash value for the SQL statement will be generated. Okay, say for example, the SQL ID will be similar to this with 13 numerical characters. Okay, so but hash value is something different. Okay, it will be in some numbers, something like 3, 2, 1, 5. Okay, so this hash value is unique for each and every statement. Also, this SQL ID is unique for each and every SQL statement. Okay. Also, optimizer generate execution plan, which is plan hash value for this particular SQL statement to access the records from either memory or database. So this execution plan should be good, or you can say it should be best out of all the other plans. So there are multiple execution plans for a SQL ID. It may be multiple or single, but that depends on the situation. But our optimizer should choose the best execution plan to retrieve the records from database. Okay, so if all these informations, hash value, SQL ID, plan hash value, are already existing in the shared pool for this particular statement, then it is well and good, right? It is called as soft pass. But again, if these details are not already existing in the shared SQL area or in the shared pool, then Oracle has to again create this particular step, shared pool check. So if these information are already existing, then what Oracle does is it will just check the syntax, it will check the semantic, then it will directly go for optimization phase. If it does not exist, then it has to pass through this shared pool check and then it has to go to the optimization phase. Okay, so how this hash value is generated? Using an MD5 algorithm. Okay, so for each and every Oracle version, the algorithm's behavior may be changing. Okay, so this MD5 randomly generate a hash value for each and every statement, and that hash value will be converted to a 13 numerical character, or you can say alphanumerical character, also known as SQL ID. Okay, and this SQL ID will be unique for each and every statement. Okay, so after all these details are generated during a hard pass, then query transformer will transform that particular query with multiple features. Okay, so I will explain it later. So after the query transformation, the original SQL query will be converted or transformed to a different SQL query internally. But you will not be able to see all those internal transformations, but in backend, this query transformer just check for the optimal way of retrieving the records, and it changes the way of retrieving the records. So even if you say select star from table, this query transformer still try to convert this original SQL query into a different format. Okay, why? Because query transformer knows the best optimization technique which will be generated by optimizer, so that is why it will transform. So once the query transformation happens, optimization phase will be continued by the optimizer. So in this optimization phase, optimizer will generate the best execution plan by checking the table statistics, and if indexes are there, then it will check the index statistics, and it will perform some permutations, and based on all those permutations, which plan or the access path which is best will be chosen. And once the best execution plan is chosen, then it will go for row source generation. Okay, so in row source generation, all those records will be retrieved. So it will check for buffer cache, or it will check for the data file to retrieve the records. Okay, and then it will go for execution phase. So execution phase will not be applicable for select statement, but it will be applicable for insert, update, and delete. Okay. Hey guys, in the last session we had seen the high level architecture of SQL processing. In this session, let us see shared pool check phase. We already know that a SQL statement, enter shared pool, and inside shared pool parsing happens inside the library cache, right? And syntax check, semantic check, and shared pool check steps are completed, right? And during the shared pool check, hash value, plan hash value, and SQL ID are generated. So if these information are already existing inside the shared pool, then that is called as soft parse. And if these details needs to be newly generated, then that is called as hard parse, right? And once these information are created, optimizer generates the execution plan to access the data from database with the best access path, right? Consider that two users, system and sys, are executing select query. Okay, first system user is executing the query. Once the query is executed, hash value will be generated. We already seen that the cursor will be representing the particular session which is executing the query, right? So when the hash value is generated, there will be two types of cursor which will be generated for that session, which is parent cursor and one child cursor. Okay, so this parent cursor stores or represents the hash value which is generated for that SQL statement. Okay, so this hash value will change even if there is a space in the syntax. So these two SQL statements are looking similar, right? So these two SQL statements can be shared and soft parse can happen. Okay, even though the users are different. So it is for specific situations, not for every scenarios. But if these two queries are similar in syntax, so if there is a dot over here and if there is a comma over here, then these two queries are different. Or if there is a space over here in the second one, even if it is a single space, still the hash value will change. Okay, exactly without any space, dot, or any comma, anything should not be there when we need to share this same SQL statement. Okay, so if there is a space over here, then this hash value will be changed. Also, the SQL ID will be different for each and every SQL statements. Okay, so in this case, the parent cursor represents the hash value and child cursor stores the metadata information of the cursor, or we can say metadata information of the SQL which is executed by the cursor. Okay, so there are multiple scenarios, but we are not going to see each and every scenarios for child cursors, as this is beyond the scope of this course. Okay, common reasons are, so if I change the optimizer mode to different mode, okay, so here I have changed to first rows. So in this case, a new child cursor will be generated, so +1. Okay, so whenever we execute a SQL statement, one parent cursor and one child cursor will be created. And if the second time I open a new session and execute the same select query with the same user, but I change the optimizer mode to first rows, then this will increment +1. So there will be two child cursors for this one parent cursor. Okay, the SQL statement is same, but the optimizer environment is different, right? So this is called as metadata. So this metadata will be stored in the child cursor. Again, I open third session and I execute the same query, but I use some different schema. Okay, so in that case, again a new child cursor will be generated. Okay, so if the object is different, okay, say for example, if user system is having an object called xtbl and user sys is also having a separate object called xtbl, but both the names are same. So in this case, the query is same, but the objects are different. So in this case, there is a mismatch. So third child cursor will be created, right? So if again, if I pass bind variables and if there is a mismatch in bind variables, again one more child cursor will be created. +1, 4. So there will be one parent cursor and 4 child cursors for a single SQL statement. Okay, so these child cursors determine whether to share the SQL or not the parent cursor. Parent cursor will only represent the hash value, not other metadata information of the SQL. Only child cursor determines the shareability of the SQL. Okay, so if the SQL is shared, then it will be good for the query execution, right? So it is a soft pass. Obviously, the SQL execute in a faster way. But if there is a mismatch in any of these environmental changes, then that will be considered as a hard pass, and there may be a performance decrease in the query execution. Okay, so let us see the sample execution plan of a particular SQL statement. Okay, so there are two plans. One is explain plan and another one is execution plan. Okay, but conceptually both are same. Both are, both the plans represent the access path of the SQL statement. But explain plan is not genuine. Okay, it will not give you the accurate or real-time execution plan. It will just provide you some estimation with some assumptions. So you should not rely on explain plan always. It is just for your understanding of how the optimizer is generating the access path for the SQL, but you should not be using this explain plan for troubleshooting. Again, execution plan is a real-time plan which is decided by the optimizer during the runtime. So when the cursor is executing the SQL statement, there will be an access path which will be decided by the optimizer. So that access path will be called as execution plan. So I don't want to confuse you at this point of time. Okay, but conceptually both are similar. Okay, so let us see some practical examples of whatever we've seen before, so that you will be getting a good understanding on these concepts. Okay. Hey guys, in the last session we had seen catching of data from data file to buffer cache, right? So in this session, let us see why the tables in data file cannot be stored in a buffer cache. Okay. So consider that this is data file and this is table, and all the data blocks of the table are stored in buffer cache. Okay. It is possible that this whole table can be cached in the buffer cache. Okay, so if you have a very large buffer cache, say 500 GB buffer cache, I'm just giving you an example. Okay, and if this table is very small, it is just 1 GB, and if there are no more tables which are stored in your database, then you can cache this table in buffer cache. That will be very helpful. But in cases of multiple tables in your database, and there are multiple large tables in your database, okay, even though you cache those tables, it will not be efficient when you see at the overall level. So if there are 50 tables, you cannot cache all those 50 tables in the buffer cache unless you have very big buffer cache. Also, we already seen that there will be cloned blocks of the original block which store the old value of the old data of the original data, right? So these are called undo, right? So these cloned copy of blocks also will be stored in buffer cache. So for that also we need some extra space, right? So in those cases, there may be buffer cache contentions. Even if you cache a particular table from data file to buffer cache, unless until that table is scanned multiple times or frequently. Okay, based on the usability, you have to cache those tables. Okay, so if you catch a big table in the buffer cache, and if most of the blocks are not being read from the table frequently, so then there is no use of catching the table, right? If you catch that big table, then all the other table blocks will be removed as part of the cycle, right? Most recently used and least recently used algorithms will be there. So if a particular block is used very frequently, those blocks will be kept in the buffer cache, and if a block is not used frequently, if it is least used, then those blocks will be removed and saved to disk, right? So it is very important that you need to consider why you are going to cache a table, and if that table blocks will be frequently accessed or not. All these conditions need to be met. Also, we need space to store all the cloned copy of the blocks, right? So that is why Oracle had introduced PGA. So it is not PGA, but it is PGA scans, which is called as direct path read. So in older Oracle versions, in 10G or 9i, when the SQL query is executed, data will be scanned in buffer cache. If it is not there, then it will go to disk, and again those data will be read, right? But in 11G, Oracle introduced direct path read, which means if there is a very big table which is stored in data file, the blocks of those table need not go to the buffer cache. Okay, it will directly go to the PGA. Buffer cache is in SGA, right? It is not in PGA. So it will directly scan those big records in PGA and it will give the results. So that is called direct path read. Okay. So you have to consider those factors. So if there is a big table which is stored in the data file, then you have to understand if PGA is used with direct path read or not. So if you are doing a full table scan, which means you are scanning the whole table. So in those cases, buffer cache reads will not help you. Okay, so I'll just tell all these concepts in the future sessions. Okay, as of now, you just understand this architecture. Okay. Hey guys, in this session, let us see the different tuning factors and tools for SQL performance. There are some things to check before tuning a SQL. So we have to check if the statistics are stale or if the statistics are very old for a particular table in the SQL. And we need to check the change in the execution plan. This is very important when we check SQL performance. You have to check the optimizer parameters as well, which may drastically change the performance of the SQL. Okay. Also, we can check the parallel usage by a SQL. This may not be an ideal case, but in some scenarios, if there is a full table scan, then that full table scan is related to a parallel table scan as well. Okay. So if there are more number of parallel servers which are used for a particular SQL statement, that may drastically reduce the performance of the database itself and bring it down to its knee. Okay, so it is always recommended to be careful when we set the parallel configuration in the database. Okay, this also drastically flood the CPU in the database. It may also cause 100% CPU usage in the database. Okay. Coming to workload comparison. So if the workload is high today and if it was low yesterday, so that should also be considered. Okay. So if there is no resource increase in the database, so in those cases, we may need to analyze if there is a need for increase in resource in the database or not. Right? Say for example, if I am driving a truck from one location to another location, from A to B. Yesterday, I just carried 6 packages in this truck, which is the minimum limit for this truck to carry these packages. So yesterday this truck was able to reach the destination on time because the truck was able to carry the load and it was riding faster. But today I add 6 more packages on this truck, which is not the recommended capacity for this truck. So it is overload, right? So today this truck was not able to pull further and it took a long time to reach the destination, right? So likewise, every device and every machines has some particular capacity and a limit to perform its task, right? If that limit is crossed, then that machine may get overloaded and there may be some accident or any impact may happen, right? I cannot expect 100cc bike to travel 600 kilometers per hour. Obviously, if I have 1000cc bike, I can reach the destination of 100 kilometers in 1 hour. I'm just giving you an example, right? So likewise, you need to check the workload and also the resource accordingly. These are all the basic tools which are used to analyze the SQL performance. They are SQL HC. So this is a health check report which gives the optimizer parameters and the historical execution plans, statistics related information, and if sometimes if the execution plan is in cursor, it may also capture 153 trays, right? It may also provide some recommendations based on its observation. Okay. SQL T report is an advanced version of SQL HC. Okay, so this contains a lot of information like plan change, so why the plan got changed, if there are any bug fixes which are related to the plan change, and if there are any fixed controls, and it also captures SQL monitoring report. Okay, so you can just think SQL T as an advanced version of SQL HC. Okay, so let us see these in practical sessions so that you will understand. And DBMS Xplan, so this gives the runtime execution plan, which is very important for troubleshooting. SQL monitor report, so this also gives a runtime graphical execution plan. So it will generate a HTML file, and you can check the resource usage as per each and every step in the plan. 146 trays and TK proof. So these two utilities are very important for analyzing the SQL performance in terms of time. Okay, so this 146 trays just divide the SQL processing into each and every phase. So as we already know that in order for a SQL to process, there are multiple stages. Okay, query transformation, parsing, execution, fetching. So all these operations are captured in this 146 trays, and TK proof is an utility which converts the raw trace file into a readable format. That's it. So these two combination of traces are very powerful. Okay, and 153 trace. So this provides each and every step of the optimizer. So it shows how the optimizer chosen a particular plan. It also shows the index related statistics, table related individual statistics. Okay, like the number of distinct values, and how many rows in the table, and index clustering factor, and the number of blocks, leaf blocks in the indexes. So also the height of the index. All these statistics are captured, and also the parameters which are modified during the execution of optimizer. So all these informations are captured. So let us see in practical session. And also we are very familiar with AWR, right? So these three are the pillars of database performance. So whenever there is a performance issue, we always check the AWR report, ASH report, and ADDM report. So AWR report collects the historical information with the help of snapshots, and it also provide you the statistics which are related to the database performance. But it does not give any individual SQL performance related reports. But we also have AWR SQRT, so that gives you individual weight related information and other information related to the SQL. But that does not give you the execution plan related information of a SQL. Okay, and also ASH and ADDM. So ADDM also gives the top SQL statement which consumes more resource, and ASH is just a sampling report which gives you the number of active users, average active users in the database during the issue time, and how much activity each and every sessions has consumed in terms of particular SQL. Okay, so ASH is totally related to the sessions which are executing the SQL. And SQL Tuning Advisor, so this is also a very common report. Whenever there is a performance issue, we execute this report. So it gives some recommendations to gather statistics or create an index or accept a profile, right? SQL Performance Analyzer, this tool is very rarely used, so it is often used for comparing the workload. So if I need to simulate a workload of a particular SQL statement, I can use this SQL Performance Analyzer. Okay, so these are all the tools which are used to analyze the performance of SQL. Okay, so coming to this mind map, so here you can see, so when there is a SQL tuning required, when there is a performance issue for a SQL, the first thing that we do is to check whether that particular SQL is actually an issue in the database or not, right? We cannot blindly tune a SQL. Okay, so in those cases we collect AWR, ASH, ADDM, OS Watcher, execution plan of the SQL statement, and we drill down further to see or to confirm if that particular SQL is consuming more resource in the database and causing performance issue. Okay, now let us see this mind map for SQL tuning. In order to tune a SQL, we need to collect certain diagnostic reports like AWR, ASH, ADDM, OS Watcher, and execution plan of the SQL statement. There are certain scenarios for a SQL statement. Number one is SQL is running fast and DB is also fast, which means database is fast. Okay. Second scenario is SQL is fast but DB is slow. Third scenario is SQL is slow but DB is fast. Fourth scenario is SQL and DB both are slow. Okay. Again, in all these scenarios, depending on the business requirements, we need to act accordingly, right? So in the first scenario, if a particular SQL statement is fast and the database is also fast, so there is no issue. Okay, the database is normal. In second scenario, a particular SQL statement is running fast, but DB is running slow, right? So in this scenario, this particular SQL statement which is running fast may be a reason for the DB slowness. It may or may not, but in most of the scenarios, if there is an issue, then this SQL statement may be a cause of DB slowness. So we have to check why this SQL statement is causing database slowness, right? So as we already seen, in a database, for example, there may be thousands of SQL query running, right? So it is not efficient if a particular SQL statement is running fast and it is slowing down other SQL statements. So that is also not an efficient SQL, right? That is also not optimal. That is a suboptimal SQL. So in this case, still we need to check a better way to make this SQL run faster without affecting other SQLs. So let us come to third scenario. SQL is slow, DB is fast. So in this case, as we already seen, in banking transactions, there may be some requirements for the business for a particular report to run faster. So in those cases, those critical reports are very important, no matter whether the database is running fast or not. So say for example, if this particular SQL is running for 5 minutes, but the business requires this SQL statement to execute in less than 10 seconds, right? So if I perform a transaction in the online payment gateway, it should run faster, right? It should not take 5 minutes in the gateway itself. So in those cases, in those kind of scenarios, we may expect SQL tuning, right? Fourth scenario is both SQL and database is slow. So in this case, the database is slow because of this particular SQL, which is consuming all the resources, but still this SQL is running slow and affecting the DB, or any other SQL statement which is consuming the resource and it is causing the required SQL to run slow. Okay, so this is just a high level example of the scenarios on when we need to tune the SQL. Okay, so in this mind map you can see different resource for related to this database, right? So if you consider a database, it should have all these resources in place. So if it is a CPU, then it may be due to high buffer gets, or you can say consistent reads, and it may be due to hard parse, and it may be due to high parallel. If it is an IO issue, it may be due to these wait events, right? DB file scattered read, DB file sequential read, direct path read, direct path write. And if it is a RAM issue, if it is a memory issue, then direct path read temp or direct path write temp. So these are IO issues, but still it indicates that PGA is not sufficient. Okay, and buffer busy waits and latch in shared pool, library cache contention. All these are issues related to SGA. And coming to network, SQL StarNet more data from DB link, SQL StarNet message from client, TCP socket. So all these are related to network calls, right? This is an overall mind map for the SQL tuning. In the next session, we'll see more about tuning the SQL. Okay. Hey guys, in this session, let us see the different SQL tuning considerations which need to be taken by the DBA for any SQL performance issue. As a DBA, you should always know your boundaries of what needs to be done and what need not be done, right? In every organization, they may be having different roles and responsibilities, right? Some organizations may ask their DBAs to perform only database administration tasks. Some organizations may blend both application and DBA tasks and ask the DBA to perform both application and DBA tasks. So it is your responsibility to check what are all the roles that you are accountable for. Why? Because whenever a DBA gets a performance issue, you get always tempted to take responsibility of the SQL performance, right? So you need to make sure that you don't get involved into something which you are not accountable for, right? So typical examples are, so if a SQL query is newly written by the development team or application team, and they are expecting that SQL to execute within certain time, milliseconds, right? But you don't have the sufficient resource in place in your database. Okay, you have only one CPU core in your database, but your database is taking the load of 6 CPU cores, say for example, but you are having only one CPU core, for example, and application team is expecting this newly written SQL query to execute in milliseconds, and this SQL contain millions of rows of tables to be fetched. So it may be practically possible or may not be possible, okay, but you need to make sure that whether that SQL is actually expected to be completed in milliseconds. If it is a new query, we don't have any baselines, right? We don't have something that says that this query should be executed within milliseconds. Like as I already told you, I have a 100cc bike and I have a 1000cc bike. So this 1000cc bike complete 100 kilometers in 1 hour, 100 kilometers per hour, but this 100cc bike takes more than 1 hour to complete 100 kilometers. But we cannot expect this 100cc bike to behave like this 1000cc bike, right? So likewise, in some cases, the business or clients may not understand that. So in development, a SQL query may execute within milliseconds, but in production, a SQL query may take more than milliseconds or minutes or even hours, right? Always do not compare production and development system, okay? Because production is something which is real time, which has billions of transactions and real time users, but development is not like that. Okay, so this is a typical example of the responsibilities that a DBA should take, right? So as I said, if 100cc bike cannot complete 100 kilometer in hour, then that is not our responsibility, right? So we need to add more resources in your in our system. Then only it will run faster. So you need to check all these considerations, and also let me go to the next slide so that you will understand more. As a DBA, you should keep these goals into consideration before any SQL performance issue. Okay. First, you need to check whether the issue is specific or not. You need to make sure about the problem statement and what needs to be done on that SQL and who will be responsible for that SQL, whether DBA team or application team, right? So that it will be helpful for justification in future. Okay. So things like whether the SQL is new or old, these questions needs to be asked. If the SQL is newly written, then there is no baseline for it, right? Baseline means benchmark. So say for example, if if an athlete run 100 meters within 9 seconds for the first time, then this is called baseline, right? Or benchmark. So that from this baseline, the next time we can see the improvement, right? If the athlete again runs in 8 seconds, we can say that he has run 1 second earlier compared to the previous run, right? But if the athlete is running for the first time, then we don't have any data to say that this athlete has completed the race in 9 seconds, right? So likewise, you should check whether the SQL is newly written or whether it is existing. If it is newly written, then DBA does not have any baseline to justify that SQL should be completed within this much amount of time. Right? So we can expect for a SQL to complete in any time, right? We can expect that SQL to complete in 1 minute or less than 10 seconds or less than 1 second or less than 1 millisecond also. There is no limit for that in expectations. But as per your resource which you have in your database, there should be at least some goals to measure, right? So those specific goals needs to be considered. Okay. The next thing is whether the goal is measurable or not. So if a SQL is executing earlier within 1 minute, but now it takes 5 minutes. So now you have a clear goal to tune this SQL, right? So the application team or client expect the SQL to run in 1 minute, but now it is taking 5 minutes. So we can see what went wrong and why it has taken 5 minutes. So there is a baseline. So this baseline is measurable, right? So if anyone complains without any data, if they blindly say that the SQL is running slow, I need the SQL to be faster. But we don't know what is meant by faster, right? For some clients, 1 minute may be faster. For some clients, even 5 minutes may be faster. But for some clients, if it takes only 1 millisecond, then it will be faster. So there should be some clear measurable goals to achieve, right? The third one is the goal should be achievable, right? The goal can be attained given the local conditions. Setting realistic goals makes the project more likely to succeed. So like as I already said, if a particular SQL is expected to run in 1 minute, that is the achievable goal. But if I say that I need this SQL to complete in nanoseconds, that is not achievable, right? So you waste your time, valuable time in tuning the SQL. Because when you open your session itself, it will take somewhere around milliseconds, right? And it has to do all the internal calls, this database processing, every internal processing needs to be done, and it has to fetch the results. So obviously nanoseconds is not possible, right? So make sure that the goal is achievable or not. Okay. Fourth one is relevant. So an objective is relevant if it makes sense, meets the grant's purpose, matches the culture and structure of the community, and addresses the project's vision. So if a particular SQL is running slow, and if that SQL is not critical to the project, right? That report is simply running without any purpose in the project, and no one knows why that SQL is executing in the database itself. And someone or any person from your team comes and says that this SQL is taking this much amount of time, so we need to tune this SQL to run faster. So here there is no relevant case, or there is no benefit in tuning this SQL, right? Even if you take time and tune the SQL, there is no use. So always make sure that the SQL that you tune is critical to the project, and it gives some benefit to the project as well. And next comes the time and cost bound. So if a particular SQL tuning issue is taking 1 year, and if it costs around more than what you tune, then that is not beneficial. Say for example, if I'm tuning a SQL which is running slower, I spend 1 million in tuning the SQL. Okay, but I get benefits of 500,000 when I tune the SQL. Then there is no use in tuning the SQL, right? There is no return on investment, or you can say there is no profit out of it. So the goal of tuning the SQL outweighs the profit itself. Also, if you consider time, if it takes 1 year for this SQL to complete, SQL tuning to complete, but your project deadline itself is 6 months, then there is no point in tuning the SQL, right? So these factors are very important. It seems that it is not, it is not applicable in a real-time situation, but it is very important, okay? And SQL tuning is an iterative process. Iterative in the sense, it goes on. There is no deadline for tuning. Okay. So once you get a SQL tuning issue or any performance issue, you check whether it is from application side or instance side or OS side. So these are all the resources: CPU, memory, I/O, network. So you collect the data, then identify which SQL is running slow, and you are tuning that SQL. Okay. So once you tune that SQL, it runs faster. After some time, you are adding some data. Some data load is happening in the database, and again, more load is appearing on the database. So again, this SQL becomes slow. So again, you need to adjust that SQL to run faster as per the updated load. So it is a cyclic process, okay? It happens and it goes long. So there is no end for SQL tuning, okay? And this is the flow chart for troubleshooting of SQL, okay? So once you get a SQL slowness issue, so first you need to collect all these reports, okay? So these are all the basic or generic report, and using this report you need to identify the problematic SQL. So once you identify the problematic SQL ID, with that SQL ID you can get SQL SQL HC report. So these things needs to be considered. So once you identify the problematic SQL, whether it is consuming high CPU discretes, whether it is passing unnecessarily, whether high executions are there, all these factors needs to be considered. And then you need to check the SQL HC report for stale stats, or whether there is any plan change or parameter changes. Then you need to take 146 trays and identify the problematic SQL or recursive SQL, right? And also you need to check the real-time execution plan and check the estimated rows and actual rows, and whether we can add any index if possible or not. So if SQL HC report is not helpful, then you can take SQL T report, which is more advanced than SQL T. Then in 146 trays you can check all these high time, high gets, I/O, CPU, okay? All these statistics can be checked. And in real-time execution plan, if it does not help, then you can again take SQL monitor report, which gives you the real-time SQL execution plan steps and their statistics. You can check for high I/O, gets, CPU, right? If none of them works, so you can do a trial and error method, okay? So you can try optimizer parameters, fixed controls, or lower optimizer features can be used, okay? So I will just explain you all these steps in practical so that you will understand. Okay. As of now, you don't need to worry about these. Okay. Hey guys, in the previous couple of sessions, we had seen the theoretical concepts of SQL execution. In this session, let us practically understand the execution of SQL. Let me connect to system user. We already created a table called XTBL, right? I will describe this table. Okay. Now let me execute a simple count of 1 from this table. I also opened another session to monitor this particular SQL, and I will also show you how the SQL ID generates for this particular SQL and the hash value, also the plan hash value for this SQL. Okay. Now I have connected using system user and I'm executing this query. I got the output. Okay. Let me open this new session. Let me describe $SQL. So $SQL is the view which contains the information related to a particular SQL, and it also contains the SQL ID, SQL text, SQL full text, all these details. Okay. Now let me get the SQL ID. Before that, let me format. Now we have generated the details for the SQL that we have executed earlier, which is select count of 1 from XTBL. Okay, so here you can see there is a 13-bit alphanumerical character which is generated, which is the SQL ID. So this is unique, and this SQL ID represents this select count of select count of 1 from XTBL. Okay, so this is the unique ID, and you can see that this SQL has been parsed one time in shared pool, right? So we already seen in the theoretical session about the parsing phase, right? Like syntax check, semantic check, all these phase happen during this parse call, and this SQL was executed once, so that's why we have 1. And here you can see the memory address of the cursor, right? And this is also unique, okay? And here you can see the buffer gets. Since we have executed this query for the first time, all the data needs to be scanned from the buffer, right? So also you can check the discretes as well. So there is a column called discretes, so let me include that as well. Buffer gets. And you can also see there are quite a lot of discretes, because all the data of this table is not stored in the buffer cache. Okay, only this much amount of data is stored in buffer cache. So this is logical IO and this is physical IO, and you can see the hash value, right? So 10-digit number. So this is also unique for this particular statement. Okay, so once this SQL statement enter shared pool, during the parsing phase and during shared pool check, the third phase, this hash value will be generated, which is also unique. And based on this hash value, this SQL ID is generated. Okay, so both are quite interrelated, but the only thing is you see a different value. Okay, but the value of SQL ID is generated based on this hash value. Okay, and you can also see plan hash value. Let me check if plan hash value is available in this SQL or not. Yeah, plan hash value is also there. So let me include that as well. And also, if there are any child number generated for this particular SQL, since we have executed this SQL for the first time, there should be one parent cursor and one child cursor generated for this SQL. Okay, that's fine. We'll see that in another view. Okay. Now you can see another 10-digit value is generated. This is the hash value. I mean, this is the plan hash value which is generated by the optimizer. Okay. So let me execute the statement again and let's see what happened. Okay, let me query this again. So you can see there are 2 parse calls and 2 executions. And here you can see the total number of buffer gets as 3794. So I have to include discretes as well. So let me include it. Okay. After seeing this output, do you observe some difference between the previous output and the current one? Everything is same, right? Except this parse call and execution. So we have executed 2 times. That's why parse calls and executions are increased, and address is same. But if you see the buffer gets and discretes, when you compare this with the previous output, buffer gets are less in previous execution, but the next execution it has been increased to 3794, but discretes are same, right? And hash value and plan hash value did not change, they are also same. So what exactly happened here? So this second output contains the sum of the buffer gets which was totally scanned for this SQL statement. Okay, it is not 3794. If you just multiply this value with 2, so you almost got 3808 as the value, so which is quite close to this one, right? So during the second execution of this query, it has again scanned the buffer cache and almost scanned 1904 blocks. During the previous execution, it has scanned 1904, that is one time. Second time also it has scanned 1904 approximately. So when we just add these both buffer gets, we got this much amount of buffer gets. Okay, so it does not mean that during the second execution it has not totally scanned 3794. It is a total of previous execution and current execution. So during the current execution there is no discretes. So that is why this value is not incremented. Why? Because all the data is cached in the database buffer cache. So that's why we don't see any physical reads. So if I again execute the same query, you will see an increment in the number of buffer gets, but you will not see any increment in discretes. So let me again check that. Now if you see, pass calls and executions are increased and buffer gets are also increased, but only thing is there is no physical reads. Why? Because we cached the data by executing this query for the first time. So during the first time, the hash value, plan hash value and SQL ID are generated in shared pool, right? And we don't need any extra parsing. Also the data blocks are cached from disk to buffer cache, right? So that's why we are not able to see any increment in discretes. So let me flush buffer cache. Okay, and let us check what really happened. Now again let me query. Now if you see, there is an increment in this discretes, right? Also the buffer gets. Why? Because we have flushed all the data from memory to disk. So currently there is no data stored in the buffer cache, which means the data blocks are almost removed from buffer cache. So that's why now again it has been incremented. So now let us again execute this query. Now you don't see any discretes, right? So now I hope you got a good understanding of how the SQL execute inside the database and how the data is cached in the memory, and also how the next time it scan the data from memory itself rather than disk, and how it generates the hash value, plan hash value and SQL ID. Hey guys, in the last session we had seen how the SQL statement parse in shared pool and cache the data in buffer cache, and also the number of executions and how hash value, SQL ID and plan hash value generate for the SQL, right? In this session, let us see parent and child cursor for this SQL statement. Now I execute a new query called select count of 2 from XTBL. Okay. So in earlier session we executed select count of 1, which is totally different. Okay. Now let me execute this query. and I also query the details of the SQL. Okay, so here you can see that discretes are 0 and buffer gets are almost this much. So this means that the data is already cached in buffer cache. So that's why we don't see any discretes, right? Also the parse call and executions are 1. Okay, so now let me execute the same query again. Now you can see parse calls are increased and buffer gets are increased and discretes are as usual 0. Now let me just give a space over here, double space over here instead of space. Okay, and let me execute the same query. So do you think that this query and this query are same, or these two queries are considered same by Oracle? So what we think may be different and what Oracle think will be different, right? As per human, these two queries are same, but as per Oracle, since there is double space over here but here only single space, these two queries are parsed differently and there will be a hard parse for this query. New plan hash value, SQL ID and hash value may be generated. Okay, so hash value and SQL ID obviously will be different and plan hash value may or may not be different. Okay, since the logic is same, right? So plan hash value may be same. Now let me just give a double space over here. Now you can see that the SQL ID is different for the double space SQL query, and parse calls become 1 and executions are 1 and buffer gets are this much and hash values different, right? But plan hash value is same. As I already told you, logic is same, right? Because both the queries are going to access the same data blocks, right? But only during the parsing phase in shared pool, there should be an extra additional syntax check, semantic check and shared pool check, right? So this is the thumb rule of SQL execution. Okay, no matter whatever space or any other difference in the query, the whole SQL ID will be changed. So if I give a space like this over here, this is also another query. Okay, now let me give a space over here. You can see that there is a new SQL ID for this query, and also the memory address is different for each and every queries, right? And also hash value is different. Plan hash value is same. Okay, so this is the thumb rule of SQL execution. Now let me flush shared pool itself. What will happen? I am just flushing all the data which were cached, which were parsed in shared pool. Okay, let me also flush buffer cache. But there is no use in flushing buffer cache. Okay, since I already flushed the shared pool, all this SQL information will be removed from memory. So there will be no hash value, plan hash value in shared pool anymore. See, no rows selected. And if I execute this query, no rows selected. No row selected. Why? Because I have erased all these informations, SQL ID, hash value, plan hash value from shared pool, right? So this is why we should be very cautious when we flush any of the memory components, because again Oracle need to perform hard parse, right? So let me switch on timing, okay, and let me execute this. So here you can see that it took almost 3 milliseconds for this query to complete, right? So let me execute this query again for the second time. So now there is no much difference, but when we execute a resource intensive query, we'll see a huge difference in the execution. Okay, since this is just a matter of milliseconds, we cannot see the difference. Okay, so now let me include let me enable auto trace so that you will be able to understand what is exactly happening. I will explain auto trace later. So let me flush shared pool and buffer cache. Now let me execute the same query. Okay. Now let me again execute this query. Now if you see, for the first time it took almost 4 milliseconds. But for the second time it took only 2 milliseconds. Why? Because the data is cached from disk to memory. But for the first time, since I flushed both shared pool and buffer cache, the data is residing only in disk and it needs to be copied to the buffer cache. So that's why it took extra time. Right? Also you can see the plan hash value, both are same. And there is a huge difference in all these statistics. In first execution there are 33 recursive calls, but in second execution there is 0. And consistent gets, which means buffer gets are high, and during second execution buffer gets are low. And during first execution you can see physical reads. Why? Because we flushed the buffer cache. But during second execution there are 0 physical reads. Right? On during the second execution there are 0 sorts in memory, but during the first execution you can see 6 sorts. So I'll explain all these statistics later. But now again we understood how the data is flushed from shared pool and how it affects the performance. Okay. Hey guys, in this session let us see the different ways to generate execution plan for a query, and we'll also see the difference between explain plan and execution plan. There are multiple tools and ways to generate an execution plan for a query. First one is auto trace. Second one is explain plan. Third one is dbms underscore explan procedure. We are not going to see much detailed information on all these tools. There are also other tools that can be used to see the execution plan, but these are all the basic checks that can be done whenever we troubleshoot a performance issue for a query. Okay, so auto trace, this is similar to a tracing utility. Okay, so this auto trace has multiple different options which we will see in different session. This auto trace first execute the query, then it provides the execution plan, and also then it gives some statistics of the query. Okay, the explain plan, this is just an estimate of optimizer's execution plan, so you should not rely on this explain plan for troubleshooting. So if you want to get an idea of the plan, then you can use explain plan, but this will not give you the actual or real-time access path which was decided by the optimizer in the cursor. Okay, say for example, so if there is a weather forecast, right? This is just an example that I'm giving. So if today I'm just forecasting that after 1 month it will rain. Okay, so after a month it may rain, yes, or it may not rain, no. There are two different possibilities, right? But today I'm just giving an estimation based on my forecasts, that's it. But during the actual day it may rain or it may also not rain. So likewise, this explain plan is used in just giving an estimation of the original execution plan, right? But we cannot always trust the forecast of the weather. Anything may happen during the original day. So that is the actual day when the climate will be known, right? So DBMS Xplan has multiple different options, and there is an option called display cursor, and inside the display cursor function you have to give some options to get the real-time execution plan. So this is very important. Okay, display cursor is very important for troubleshooting of any SQL performance issue, because this gives the actual runtime when the optimizer decided the execution plan for a query in the cursor, or you can say real time. Okay, so as per this example, so during that particular day it didn't rain, it was sunny. So this is the actual climate of that particular day, right? So likewise, this display cursor will give you the actual execution plan which was decided during that particular execution of the query. Okay, so these are all the basic tools. So let us just see how we can use those. First, let me set auto trace for the query. Set auto trace on, and just execute a simple query, select count of star from XTBL. So here you can see the output of the query. So this auto trace has executed the query. Then it has given you the execution plan details, and there is a note section. So this note section is optional, and we can also see statistics session, right? So I will explain all these individual components in a separate session. So as of now, just we can learn how to generate the execution plan. Okay, so this auto trace utility queries a table called plan table. Okay, so this view is very important. Okay, always you should remember this view, because this view also contains the execution plan information of a particular query. If you cannot generate these auto traces or any other using any other tool, if you cannot generate the execution plan, you can directly query this view. So I will just give you a sample execution plan from this plan table. So where plan hash value, where is the plan hash value? Okay, so I'll just filter with operation, where operation like give this plan hash value. So since I have enabled auto trace, it has given some output over here. Okay, so I will just set auto trace off. So always you should remember this. Whenever you switch on auto trace, you should switch off auto trace as well. Otherwise, you will get the output for this query itself. Okay, so this select operation from plan table where operation like this predicate is there, right? So for this query, auto trace has generated an execution plan. Okay, so now let me just query the execution plan for a random table. So now we can see it has printed the operation for a random table, right? So let me just give select star from plan table. So this plan table stores the execution plan information into bits and pieces. Okay, so you have to format the execution plan with this plan table view. Okay, so we need to query this table in such a way that it prints the execution plan in a very neat format. Okay, so now let us see explain plan. Explain plan for select count of star from XTPL. So this is the syntax. You have to give explain plan for followed by the original query. So it will give you an output called explain. Now you can select star from table dbms explain dot display. Now you can see an estimated explain plan for the optimizer. So this is not the exact execution plan. Okay, you should not rely on this. So the next one is dbms explain.display cursor. We should check the statistics. Okay, so this statistics level and time statistics are very important. I will explain it later. So you should set this statistics level in your session to all. Okay, and currently the value is already all for my session, but in your session it may be typical. Okay, so once you set this value, you have to execute the query. Now select star from dbms, it should be table dbms explain dot display cursor. Here you have to give null and advanced all stats lost. Okay, so this is the most important tool which you should remember. Why? Because always whenever there is a performance issue for a SQL, then you will use this tool. Okay, why? Because this tool gives you the real-time execution plan. So here you can see the SQL ID, child number. I will explain all these in later session, but as of now, just see what this tool has given you. Okay, so you get the estimated rows and estimated time of optimizer to retrieve the data, and it has given the actual rows and actual time it took for the optimizer to retrieve the data. So these actual rows and actual time are very important. Okay, so it also given the outline data of the query, column projection, query block registry. Okay, so you can see that there is a very huge difference between the estimated rows and the actual rows, right? So here estimated rows is 1 and actual rows. So let me format this so that it will be easy. Yeah, so here the number of estimated rows are 8.68, but here you can see that actually optimizer has fetched only 51 records, and the estimated time for the query is 1 millisecond, and actual time taken is 3 milliseconds, right? So there is a huge difference between the original execution and the estimated execution, right? So that's why we don't rely on explain plan for troubleshooting. Okay, so these are all the tools that can be used to generate the execution plan for a query. So you can just practice these options and just have a look at all these options, and okay, we'll explain all these outputs in a separate session. Okay. Hey guys, in this session let us see two different parameters called timed statistics and statistics level, which was already seen in the execution plan session. These two parameters determine the level of statistics that can be collected in the database when it is up and running. Okay, statistics in the sense all the performance related statistics of this particular instance. Okay, so whenever you see this parameter value, it should be either typical or all. Okay, it should not be basic. So there are three values for this parameter. Okay, if it is basic, then just think that the statistics collection level is off, switched off. This database no longer collect any AWR data or ADDM data or any OS statistics or any optimizer statistics collection. None of the important features related to performance will be collected in your database. Okay, so it is always recommended that you have to set the statistics level at least to typical. So typical collects most of the important statistics related to the database, and all collects the timed OS statistics and the planned related statistics. This is the only difference. Okay, so you don't need to remember all the features which are collected by typical and all. Okay, you just remember only the difference. Okay, typical collects almost 90% of the database performance statistics, and the only difference between typical and all is it collects all collects time OS statistics and plan statistics. So timed OS statistics is something which collects the operating system related statistics like CPU, memory and network, all these stuffs. Okay, this is not that much significant for SQL tuning. Okay, it may be rarely used. Okay, but planned statistics is very important. Okay, so whenever you tune or troubleshoot a SQL performance issue, you should get almost all of the plan statistics to drill down the issue, right? So you should be always setting statistics level to all at session level like this. We already seen in the previous session, right? Statistics level is equal to all like this. Okay, so this does not affect the whole database. If you just see show parameter statistics, now you can see statistics level has been changed to all, but if I open a new session, the second session statistics level will be still typical. You can see, right? So it will not affect the whole database. So other users will not see this change. Only your session will be having this change. And also you should be careful when you set it at the system level. Okay, typical is well and good, okay, for your database performance. But if you set to all, then this may affect the performance of your database also, because additional overhead will be given to your database because of these two statistics. So that is why Oracle has not included these two statistics with typical. Okay, because every time you will not use these, only during troubleshooting of specific SQL issue you will be using these plan statistics. So it is not recommended to set statistic level at system level. Okay, but there are some databases where the business may require this statistics level to be kept to all the time. Okay, so that depends on the business requirements. Whenever statistics level value is set to either all or typical, we cannot be able to set time statistics to false. Okay, so if we set statistics level to basic, then only we can set time statistics to false, which means we cannot switch off time statistics when statistics level is either typical or all, to reiterate. Okay, so if I set statistics level to basic, now I am switching off all the performance collection in the database. Now you can see both the parameters are disabled. Now none of the performance related information are collected. Okay, again I am enabling the value. Okay, so there are also other parameters which are related to statistics, which is client statistics level and timed OS statistics, right? So these two parameters are beyond the scope of this course. Okay, but still client statistics level determines the network related OS statistics when the client execute a particular query. So if I'm using SQL developer, so there should be some time which is taken to perform the network calls, right? So those statistics will be collected if it is typical. And this timed OS statistics collects all the information related to the OS statistics at a specific interval. So this is the interval value. Okay, so as per the interval set, it will ping the OS to collect all these statistics. Okay, so I hope you now got a high level understanding of these two parameter importance, statistics level and time statistics. Okay, so whenever you perform SQL tuning for a particular performance issue, you should always set the statistics level to all to get the planned the planned statistics. Okay.